In this video, we're going to take a look at using Test Editor to create stimulus tests. Now, before we get started, I want to point out that the stimulus library is built on C#. A lot of what you're going to see in this video is going to be C# related code. So we highly recommend that you're familiar with C# prior to trying to build a stimulus test. Here's a great C# tutorial available from Microsoft. The link to this tutorial is on your screen. And you should also find a link to this in the stimulus help file provided inside of Test Editor. We highly recommend you go through this and have a basic understanding of C# prior to writing your tests. With that said, we're going to dive in and take a look at how to make stimulus tests. So to get started, I just want to set us up with a blank test, and then we're going to walk through and look at a few of the important aspects of Test Editor. So I'll just go to Test Editor, New, and for now I'm going to do a UniPro stimulus test. This dialog pops up and you have to give your test a name as well as select a category. You can drop this down and it'll show you all the categories that are available in your document folder at the current moment, or you can create your own, which I will do by just typing stim demo. For the name of my stimulus test, I'm just going to call this sample UniPro. And when I'm ready, I can click OK. And if that test happened to already exist, it would have warned me and I would have gotten an error. In this case, it did not. Now, there are a few panes that are very important that you have up and available for you while you're writing these tests. Any of these that are missing can be brought back through the View menu. Number one, the Solution Explorer. This shows you your solution, your project, and all the relevant files for your test. You have to have this up so that you can access the files. The most important file is usertest.cs. I'll double click that. This opens up on the left-hand side or wherever you happen to have your document view. And this is the body of your test. This is where all the work is done. This is where all your executable code will be written. And we'll go through what all these different classes are and where you actually write the code here in just a moment. Now you also have the error list window, which is down here at the bottom. This window is pretty important because if you happen to have a syntax error, so for example, if I just type some extra characters, you'll see I get an error. Test type does not contain a definition for UniPro gobbledygook. So if I double click this, it will take me to that error, and then I'm able to fix whatever was wrong. So the error window is something you want to keep your eyes on as you're writing the test because it'll be a great source of information if you've got problems. The other window you're going to care about is the output window. Right now there's nothing in here, but when we go ahead and build the test here in a little bit, all the build information will come out here, and this is where you'll look to see if you have any errors building or to see that your test did build successfully. So let's start diving into a test itself, and I'm just going to scoot a few things down so we have more room to look at the actual test. There are many methods inside this usertest.cs class, and the top one here is the test type. This test type is a property that tells the system whether this is a UniPro or UFS test. Because we opened the UniPro test template, we are a test type of UniPro. You have a should run, and in each of these methods there should be a little comment that tells you what they are. And the should run method is set up so that you can check to make sure that things in the application software are set prior to this test being allowed to run. So you can see here it says if you uncomment the following lines, the test will only run if TC0 TX max SDU size is less than 272. So I could uncomment that. You can highlight the lines and there's an uncomment button here. And now you're checking the device values and you're looking to see that this is less than 272, and if it is, you're going to return false. You would then have to do other checking to see if there's other properties that you care about, and if all the pre-run conditions are met, you can return true. So by default, when you open the template, this section of code is commented out just like this, and this method just returns true, meaning the test is allowed to run. Now, the most important method, and this is where you'll do most of your work, is this test body method. This is where you'll write all the code that defines what's going to happen while your test is running. You can see by default, all it does is return true. We give you a little reboot Unipro command here that again is commented out, that if you were to uncomment would basically run one command, and that command would boot the Unipro stack. Now again, we put this little text in here to tell you this is where you define your stuff, but I'm going to delete some of this just so we have some space and we can define our own pieces and parts and make this test. The most important thing that you need to understand in here is the stimulus library. The stimulus library is where you get all of your tools and all of your functions and all of your methods to interact with the hardware and ultimately interact with your device. For a UniPro test, you see we have by default the UniPro Exerciser and Status Tools class already set up and ready to go in your test. That particular method is known as tools, so that's how we're going to access it. And you can see that it was set up as from the toolkit as a UniPro tools set. Now, all of this information that we're going to be covering is also covered in the documentation. We are not going to cover nearly everything that is in the documentation. We're going to cover the basics of how to use all these tools, and if you need further information, you can check out that reference. That reference is found by going to Test Editor, Help, and selecting the Stimulus Editor API documentation. So once this opens up, this is your home for documentation on all the pieces and parts that you'll find in the Stimulus Editor. Now, as we expand the Stimulus Editor and offer more functionality, we will also be updating this documentation. You'll see that there are two namespaces, shared types and test and automation, and I'll just expand the contents on the left to show those same two namespaces. And this is where you go to find out everything you need to know about all the methods, properties, enumerations, you name it, that exist in the actual library. So for example, shared types DME basically holds information that helps you identify what sort of DME operation you're performing. So you have a config result code, so you'll know the result of your configuration command. You'll see that I can set the DME operation, whether I'm doing an operation for get or set. DME selector lets me choose whether I want to run the DME command on my local DME or in the peer DME. So these are used, and all of these shared types are used as references when you're setting up commands and calling other methods. And we'll look at these as we start to do our sample tests. The test and automation namespace is where you're going to find most of the commands that are available to run against your hardware. So for example, if I go into test and automation and look at the UniPro Exerciser and Status Tools class, which is the one that is already enabled and set up for you in a UniPro test, you'll see down here all the methods that are available. Boot UniPro is the one that we already have in there to reboot UniPro. Configure a test source is what I can use to actually set up a device test source to send packets. I can do DME gets, DME peer gets, and the list goes on and on. So look through this documentation. It'll tell you all the things that you're able to do with the hardware, but also some of the IntelliSense, which is the sort of help you code logic in Visual Studio, will also help you as you're setting up your methods and creating your scripts. So I'm going to close this out. And the best way to get familiar with some of this is to just go ahead and write some test cases. So we're going to start by writing a very simple UniPro test case. We'll start with this tools class that we already have declared, and we're going to use this object to do some other things. So first of all, in our test, we want to go ahead and boot UniPro is actually fine. So I'm going to uncomment this particular line. So that will make sure that the first thing the test does is make sure the device is booted and online and ready to go. Now what I want to do is a very simple DME peer get. I want to grab an attribute from my device and store that attribute in my test. So to do that, I'm going to use tools, and I'm going to just type dot, and I get a list of all the different methods I can call. And in this case, I want to call DME peer get to do a peer get. Open paren, and now it's going to start asking me for the parameters. You'll notice it's already sort of dropping down and suggesting that I use Unipro Attribute Id because the first parameter happens to be Unipro Attribute Id. So I will use that, so to accept what it's offering me, I can just hit enter. And I'll hit dot, and the attribute that I want in this case is PA underscore TX skip. And you can see that I've typed it in lowercase. It actually has to be typed, it's all case sensitive, just like you see it in this drop down. So I can actually just hit enter or tab and it will accept that and correct the spelling for me. It's the great thing about IntelliSense. Comma, and you'll see the second parameter that it's asking for is the gen selector index, and it even tells you down here what it's looking for, the gen selector index. And in this case, I'll use a gen selector index of 0. Alright, so if I were to run this script now, it would boot and it would run this peer get, and that data would be in my trace. I can go one step further. If I don't want to look at the trace, I can actually have my test look at the results from this particular peer get, and I could continue to act on that particular set of information. So to do that, this method, DME peer get, actually returns some data. And if you hover over it, you can see the full definition of the attribute right here, and you'll see that it returns a DME config result. So in order to get that return, I have to declare a DME config result variable that I then allow this method to return its data into. So I'll start that by just going to the beginning of the line, and I'm going to declare DME config result, and I will just name it read result and set that equal to whatever returns from this DME peer get. So that's my peer get. Now I could just use this information to see if I want to move on to another command, or I could print this information out to a debug console, or I could just ignore this information altogether. For the purposes of this test, I'm going to go ahead and print it out to a debug console so that we can see it when we actually come in here and walk through this test in debug mode here in just a little bit. So to do that, I'm going to use a command called debug.writeLine. So I'll type that in, and you'll notice right away that Visual Studio has thrown little squigglies under this, and that's because it doesn't understand what this debug class is, and that's because I don't have the proper reference set up in order to use it. So Visual Studio again can help you with that. You'll see this little light bulb has popped up over here on the left, and if I hover over that light bulb, there's a little drop down, and if I drop down, it says, hey, I can fix this by adding a using statement or by fully qualifying this debug class. So this debug class happens to live in system.diagnostics. So if I just go ahead and say use the using statement, what that does is at the very top of my file puts in a using system.diagnostics call. All of these using statements are basically shortcuts to say that I want to be able to use this namespace, and I can then start using the things that exist under diagnostics without fully qualifying that name. Again, using statements, very common in C#, and you'll find more information about that if you go through the C# tutorial. So I use the Visual Studio IntelliSense to fix my problem, my using statement's in place, and now I can use my debug write line. So debug write line basically takes a string or a value or something, and it's going to write it to our debug output console while we're debugging this test. And so what I'm going to do is basically put a string together that displays the information from this read result. So to do that, I'm just going to go ahead and type quote, quote, and then semicolon. So right now that would just print an empty line. Now what I'm going to show you here is kind of a trick of C# and string formatting, but if I start this with a $sign, what I'm telling it is that I'm about to specify a string that's formatted, and I need you to insert values into my string that come from other variables. So I want my string to say peer get returned result, and I want another result. Well, to get the result, I can actually do a couple of curly braces, open and close, and inside that curly brace, I can specify some variable or object from my code and get its value, and it will be inserted into my string. So in this case, I want the value from read result, and so I'm going to type read result, tab, dot, and the thing that I care about is the config result code. I want to know what config result code was returned when I did this peer get. I also want to know what value it read because this was a peer get, so I want to know the value. So I'll just continue my string after I close my curly brace and type end a value of, and now I need to get the attribute value from read result. So same thing, I can open a curly brace, read result dot attribute value, and I'll close the curly brace. So I get my attribute ID value back and my config result code. So this information will print to this debug console as we are going through and running the test. Now that I've read, what I want to do is go ahead and write this same attribute to a different value, and then I want to make sure that it actually successfully wrote the value. So I'm going to do a write and then a read. So a DME config result can be for a read or a write, so I'm going to declare another one. This one I'm going to call a write result, and I'm going to set this equal to, again we're going to use our tools, and I'm going to do a DME peer set this time. Open paren, same attribute. I want to set the Unipro Attribute Id, so Unipro Attid dot, same one, PA TX skip. And in this case, I want to set its value to 1. So first I specify 0 for the gen selector and 1 for the actual MIB attribute value, and parenthesis. And now I will go ahead and write this attribute on the peer to a value of 1. Same thing, I'd like to go ahead and make sure that the value was written, so I want to check the result. So after this write, I'm going to just paste a line in here. It's going to be very similar to the one you saw above, where I do a debug write line, and in this case I'm going to say the peer set returned result, and then the write result config result code. So I'll know that it returned a successful result when I wrote the value. Now last but not least, I want to read it one more time and make sure that the value is in fact changed. So I'm just going to copy this particular code here, these 2 lines, because that was what did my read, and I'll paste them down here. And the only thing that I have to change, you'll notice read result here gets a bunch of squigglies because it's already been declared on this line. So my choices are name this something else, so I have like a before and after read result, or just reuse read result by not declaring it again. I could remove the type. So if I do that, now I'm reusing read result. But I want to maintain both my before and after, so I'm going to say read result after in this particular variable, and then I just need to make sure that I replace the read result here with read result after. So I just copied and pasted. That way what prints on the line here will show me the after value, not the value that existed prior to me writing. And that's basically a very, very simple stimulus. Now I could have gone in and done, hibernates and sent data frames and peer gets and power mode changes, and all that's available in the UFS and Unipro tool sets. But in this case, I just did a very simple peer get followed by a peer set followed by another peer get. So I want to go ahead and show you how to run this in the application software. But before I can do that, the test actually has to be built. And if it's not built, you'll actually see an error in the app. So I'll show you that first. I'll just hit save. So my test is saved. I'll check my error list. I have no errors. This is good. So everything seems that it's at least on the surface written correctly. So if we flip over to the application software, and in our configuration window we scroll down to our test list, you'll see our stim demo folder. And if I expand that, you'll see our Unipro demo test is here, but it's grayed out. If you hover over the little warning icon, it will tell you that the test is not executable and you may need to build your test. And that is in fact true. We have not yet built this test, so it can't be run. So we'll switch back to the builder, and to build the test, we just have to go to Test Editor and select Build Stimulus Test. Now what you want to do, you might get this message saying that the user config has been modified outside the environment. That's okay. You can say yes to reload it. But what you want to do after you've run your build is go to your output window and make sure that regardless of what you see up here, any warnings you might see, what you want to see is at the very bottom, build 1 succeeded, 0 failed. That means my test has built correctly, and I now should be able to execute it in the application software. So if we switch back, we'll see that our Unipro demo test is now not grayed out, no warnings, and we can go ahead and select it. So the first thing we need to do in order to run this test is connect to our hardware. So we'll go ahead and do that. And you'll notice that I could click the boot button here to bring my device up, but we made the Unipro boot the first line in our script, so we don't have to do that. It'll be taken care of when we run our stimulus test. So I'll start the analyzer. I'll start the stem. It says stem test complete, and we'll stop the analyzer. So we've got our capture, and you'll notice what the first thing that happens, we see some trig UPR 0, so we've definitely started a boot process. I'll go to traffic overview so we can skip down to the end of the boot by going to our capabilities exchange. Let's double click that. And you'll see that the device is now booted. Now, if we look at our traffic overview, we have 2 PACP gets and a bunch of PACP sets, but some of that's involved in just booting the device. But let's take a look at the first PACP GET request. You'll see here we have a PACP GET request from the host where it was asking for PATX skip, which is the value we were requesting in our script. Here's the conf, hopefully returning a value of 0, it did, and a config result code of 0, which is success. We then went ahead and did the set. So here's the set request to set PATX skip to a value of 1. Here's our conf, again with a successful result code. And here is the second GET request where we ask for PATX skip, and in this case it should return a 1 because of our set. So that's basically how you run a stem script. Now, we also put those debug prints in there, and those aren't going to show up in the application. Those are only going to be available when you debug your test case, which is what I'm going to show you how to do now. So if you want to debug and step through this test case line by line, or check certain values or check certain properties, you can do that. First of all, you'll need to set some sort of a breakpoint in your test body. You can do that in one of two ways. You can click out here in this blank margin to the left of these line numbers, and you'll see I get a little red stop sign. Or I can pick the line that I want to set my breakpoint on, and I can use F9. You could also right click, go down to breakpoint, and then insert a breakpoint. Usually F9 or clicking in the margin is a little bit faster and a little more convenient. So now I have this breakpoint set up. Now I need to start a debugging session so that it will actually jump in here when I hit this breakpoint. To do that, you go to Test Editor, and you're going to select Debug Stimulus Test. And you'll notice now Visual Studio will go into a debugging mode. You can see I have a stop button up here if I want to get out of the debug mode. It tells me what process I'm debugging, and I can now go back to the application software. And this time when I run my test, it's going to jump into my editor when it hits the breakpoint. So I'll have my analyzer started. So now this time when I go ahead and click Start Stem, you'll notice it jumps back into the editor, and now I'm in a paused state, and you'll see that I'm in the middle of debugging. This is the line that the breakpoint was on, so this is the line that's about to execute. Now a couple commands you might care about. Step over and step into are two things you're going to care about when you're debugging. Step over will step over this line and run it. Step into would actually step into any functions that are there if you have access to that code. You can access those buttons up here, step over or step into, or from the debug menu, you have your step over and step into here, or as you see from the reference, F10 would be a step over. So we're going to use F10 to go a line at a time. So I'll just hit F10, and now I'll have booted Unipro. Now keep in mind when you're debugging, your times in your trace are going to reflect the time that you sat here staring at the test case. So if you're trying to do something where you're checking for performance or speed or throughput, certainly debugging is going to affect that greatly. Now I'm going to go ahead and step over this DME config result. And one of the things you'll notice, there's a few really helpful windows when you're debugging. One of them is called your locals window. So if I click this locals tab down here, it shows me a list of all the variables that are in my local function. And in this case, one of the ones I care about is read result. So you'll see here's my read result, and it has a little arrow next to it, and I can expand it and see everything about that DME config result. The attribute name that was written was PATX skip. That's the actual value, and if you right click and select hexadecimal display, you'll actually see the value that you'd expect from the spec 155C. You can see the value is 0. The config result was a success. So I can see everything about what was in this read result. I can also hover over it in the editor and I can get a very similar display. So I can quickly see what values are set in any one of these declared read results. Now this debug write line that we put in, I'm going to F10 over that, and what you'll see in Visual Studio is that in my output window I now have that information. So when I'm building my test, the output window is great to tell me whether or not my build was successful, but when I'm debugging I can see that the peer get returned result success and a value of 5468, and actually the value returned was 0, but you'll notice we accidentally put attribute ID value, so we actually returned the value of PATX skip. So since we're debugging, we see we made a slight error, so we can fix this later to make sure that we output the value, the attribute value, not the attribute ID value. But that's a minor thing, and we can see in our locals window that we got the value we expected. So we'll just go ahead and F10 over the right, and you'll see there that the peer set returned a result of success. My right result down here now has information to see what value was set and what attribute that value was set to. And then we'll just issue one more read, and now you can see my read after down here shows that my value is a 1. And my output window also said that it returned a success. This will return true, and if I hit continue, that just sort of says run till you reach the end of the script or a breakpoint, so we'll do that. And we go back to the application software. So then when I hit stop, we should see the same information we saw the first time we ran the script, but if I go to PACP get request, we'll go to the first one of those, you'll notice that the time between my PACP get request and my PACP set requests starts being fairly long. We're talking in seconds, 254 seconds, because the analyzer was just sitting here the entire time waiting for us to step through our code. That's how you debug a test case. Now debugging, we did find that we had an issue with this attribute value. So if I stop this, we can just change this, and we don't want the attribute ID value, we wanted the attribute value. So I'll just change that, and I did that just by deleting what was there, and I retyped my period, and there's a couple of shortcuts that can bring these values up as well, but that's usually a quick way to do it, and we'll do attribute value. Now what I'll do is just set my breakpoint at the return so that we can just see what the test does and everything that gets printed out before the end of the test. So again, we will just go to Test Editor, Build, Test Editor, Debug. And once we're in debug mode, we'll flip back to the application software. We'll start the analyzer. We'll start our stim. And you'll see now it's run the entire test, but it breaks right at the end. So I could go back and review any of these results that I want, or I can look in my debug output, and you'll see it returned a value of 0. The set returned success, and then the get returned a value of 1. So I can see that everything happened in the way that I expected, and my script has succeeded. So I'll just clear this breakpoint by clicking on it, click F5, that should return me to my application software, hit stop, and my stim is complete. We've only touched on the surface of the power of what you can do with the stimulus tools. So I encourage you to go read the Stimulus User's Guide and also spend a little bit of time in that Stimulus API reference. And again, those can be found on the Test Editor menu, Help. You have your UniPro Stimulus Editor Manual. The UFS Stimulus Editor Manual will be up shortly. And then you have the Stimulus Editor API documentation, which will really tell you all the different methods and properties that you can run in both your UniPro and your UFS tool sets.